Good afternoon. Good afternoon, everyone. Hi. My name is Paul Ryer. I'm the Director of Scholar Programs here, and it is my pleasure to welcome you to today's talk by Professor Zaneta Thayer. I will have a few announcements first, and then I'll introduce our speaker. So let me start off with the double doors behind me are our fire doors, and should there be any need, they're open. I'll get that screen up and we'll go out that way. Okay, so important to know. That's a new thing that we're trying to sort of spread the word about, fire exit. We have a couple of forthcoming events. Next Tuesday, February 3rd, Indigenous Care Collections Guide webinar at 1 p.m. Tuesday, February 10th, the Art of Coping webinar. And then Wednesday, February 18th, Candy Martinez, Professor Martinez is here somewhere, I believe. There she is, presenting a colloquium, Emotions and Healing in Indigenous Oaxaca. That, normally the colloquia are 2 weeks apart, but because of our board meeting coming up, we've shifted it's 3 weeks from now. So that's, I don't want that to throw anyone off. Okay, so February 18th, our next colloquium. And thanks to our sponsors, As Above, So Below, Patricia Foshi Charitable Fund, Andrea Fisher Fine Pottery, Thornburg Investment Management, Dan Marian's UBS Financial Services, Santa Fe Dining, and Shiprock Santa Fe. Thank you all for your support of this program. It is my great pleasure to welcome today's speaker. Professor Zaneta Thayer is professor in the Department of Anthropology, Associate Professor of Biological Anthropology in the Department of Anthropology at Dartmouth. She completed her PhD at Northwestern University and is here to talk about the book project she's working on, Each of Us is Born. Please join me in welcoming Professor Zaneta Thayer.
All right, hello everyone. Thanks so much for joining me here today. I'm really excited to talk to you about a work that's very much in process, we might say early in its gestation. But yeah, I'm excited to share with you some of the ideas that I'm working through and hopefully teach you some things that you might not have known already. So, on April 4th, 2018, I was sitting in a waiting room reeking of antiseptic spray and music. It was 8:01 and the clinic had just opened. I was 29 weeks pregnant and scheduled for an oral glucose tolerance test. In the US, this testing is a common part of prenatal care since untreated diabetes during pregnancy, known as gestational diabetes, can lead to pregnancy and birth complications. The test involved drinking a large sugary beverage containing 100 grams of glucose and having my blood drawn a total of 4 times, once per hour, to see how well my body could absorb the glucose into my cells. It was hell. To start, the test had to be done after fasting all night, so I was starving. Having a large sugary drink on an empty stomach caused me to have nausea. I was also really anxious. As a lifelong nerd who's made a career out of never leaving school, the idea of failing a test was mortifying. Unlike an academic test, no amount of studying the night before was going to help me pass. Did I mention it was also my birthday? Well, I could have scheduled the test for another day. As soon as I found out it was needed, I wanted to get it done as quickly as possible to move on from the uncertainty and stress. The next day, I got a call I'd hoped for. I learned that, like the vast majority of people who have to suffer through this half day of being a human pincushion, I did not have gestational diabetes. I was reassured, but not relaxed, far from it. The testing experience, like so many we experience in contemporary pregnancy, had itself become a source of stress and anxiety. What I didn't understand at the time was why people who have never had an issue with blood sugar before need to take this test. It turns out that during pregnancy, our blood sugar metabolism changes, and so even those of us who have never had issues with blood sugar before can develop gestational diabetes. But why does it change in the first place? Like many changes our bodies undergo during pregnancy and birth, this experience has been shaped by our evolutionary history. In the case of blood sugar during pregnancy, our babies have evolved to manipulate maternal biology to ensure they get the nutrients they need. The placenta, an organ that's grown by the fetus, releases hormones during pregnancy that make our bodies less sensitive to insulin. You can think about insulin as a key that cells need to absorb glucose. No key, no absorption, meaning that glucose levels stay high in the bloodstream. These high levels of glucose in maternal blood are then transported to the baby, helping them to grow. The shift towards increased insulin resistance during pregnancy is found in many mammals, and likely reflects the fact that our offspring have evolved mechanisms to ensure a steady supply of nutrients, even in cases where mothers have inconsistent access to food. The issue is that this deeply evolved biology has become maladaptive in the current context that many humans find themselves living in. For one, many of us are not living in an environment where our access to calories is restricted or uncertain. The only foraging I need to do is moving food from the grocery shelf into my cart. And now I can do that using a virtual grocery cart on my phone. Rather than traveling miles every day to gather water or food, I type, or when teaching, talk, neither of which burns many calories. So obesity, which is a key risk factor for gestational diabetes, has increased for many of us. The idea that our evolved biology can sometimes be at odds with our contemporary environment is what evolutionary medicine researchers call evolutionary mismatch. And it's been used to explain a lot of different contemporary health conditions. One example is an increase in breast cancer that we've seen in high-income countries like the US across the 20th century. So the idea here is that over the last 150 years or so, in the US and many other high-income countries, we've had changes to our infectious disease exposure and increased nutritional availability, both of which have decreased our average menarchal age, aka the age when we get our first period. At the same time, we've changed our reproductive scheduling, right? So we have access to birth control. So we have a lot fewer kids, and we have kids later on. This means that, on average, many of us will experience hundreds of menstrual cycles across our life course, 300, 400 cycles, whereas many of our ancestors might have only experienced cycles on the order of tens of cycles. And so each time our body goes through the menstrual cycle, it's being exposed to different reproductive hormones, things like estrogen. And so it's hypothesized that this increased exposure to cycling estrogen across menstrual cycles has increased the likelihood of developing estrogen-positive breast cancer. So besides mismatch, another important thing to understand when deciphering how evolution has shaped the reproductive experience is that evolution increases our overall reproductive success, not exactly our happiness. Thus, aspects of the reproductive experience, which include pregnancy and birth, are sometimes uncomfortable or unpleasant, but likely occur because they increase our overall reproductive success in ways that may not be immediately apparent. So as an example, it's been hypothesized that nausea and vomiting in pregnancy, which I can account from personal experience is miserable, may be a behavioral adaptation to encourage pregnant people to avoid ingesting foods that could threaten fetal well-being during the first trimester when the fetus is particularly sensitive. As another example, a moderate amount of fear about childbirth has been argued by SAR's own Dr. Wenda Trevathan to be adaptive if it encouraged individuals to seek assistance during labor, thus increasing maternal and newborn survival in instances where assistance is needed. And so in the book I'm writing during my time at SAR, Each of Us is Born, I'm addressing many of the aspects of pregnancy and birth that we experience as sometimes suboptimal, stressful, or dangerous, and considering how our evolved biology, current environments, and sometimes the interaction between the two contribute to these experiences. To do so, each chapter begins by describing the underlying biology before considering evolutionary explanations for why that biology may have evolved. And then we'll turn to a discussion of the current environmental context to consider how it may improve or at times exacerbate that reproductive experience. So obviously there's a lot of things that I'll be covering in my book that I don't have time to go into today. So for the sake of time, I'm just going to talk about a couple of things: early pregnancy loss and due dates or gestation length. Before I kick that off, I do want to just provide a little bit of extra background that's helpful by thinking first, what are a few things that are unique about human reproduction? This could be a whole talk in itself, but just to pull out a few things relevant to our conversation today. First is that human pregnancy is long. Any of us who have been pregnant know it certainly feels that way. But actually, when we compare human gestation length to the length of other primates, and we look at our body size, we find that human gestation is actually 37 days longer than we predicted compared to other apes based on our body size. At the same time, we give birth to babies that are quite big. So these are data put together by my colleague Jerry De Silva, And he estimates that human newborns are 5 to 6% of their mother's size at birth. In contrast, chimpanzees are a little more than 3% and gorillas a little less. So we grow big babies. Because our babies are big and because our pelvis has changed across our evolution over the last 3 to 6 million years, our babies actually have to rotate on the way out of the birth canal. And so what we're looking at here on the right is a picture of a pelvis if you're looking from the front. And you can see there's 3 different red lines horizontally going across. And those represent the different planes of the pelvis, the inlet, the mid-plane, and the outlet. And the important thing to understand is that the widest point at each of those planes is actually different. And so for the baby to come out, they have to actually turn their head and shoulders to make sure they can descend. So this results in what's called the cardinal movements of labor, right? So as our babies come out the birth canal, they're rotating. And so because of this somewhat long and protracted labor, most human populations, unlike most primates, have evolved assisted labor. This has also been argued by Wenda to be a really important part of our evolutionary history. I won't talk about this a lot today, but I do want to plug a panel discussion we're having tomorrow with Wenda and some wonderful colleagues from IARC, where we're going to be talking about more of the social, cultural aspects of the reproductive experience. So check that out. We're going to go to the IARC to look at actual objects as well. Okay, so let's turn to talking a little bit about early pregnancy loss. Again, thinking about these different levels of explanation. So a question I want to open with is now or never. My students have told me about a game they play with their friends. The premise is to ask each other whether they would rather have a child now or never. Some responses they share with me are, baby never, I want to go to medical school, I have too much education ahead of me. Baby never, I'm not mature enough at this point in my life. Baby now, I love kids, I want a big family. Baby now, having children has always been a given about my future. So my students' game hints at a cultural phenomenon that's recent from an evolutionary perspective. The fact that we can control, with reasonable effectiveness, when we have children. Since the current demographic trend is to delay childbearing, what many of us initially control is our ability to avoid pregnancy. Access to safe and effective birth control to delay childbearing is not something to take for granted. As Laura Friedenfeld describes in The Myth of the Perfect Pregnancy, women my students' age living in New England 300 years earlier would have had little control over their reproduction, and as a result would have spent most of their adult lives pregnant or lactating. Friedenfeld argues that this ability to delay reproduction through birth control has completely reshaped our expectations about our ability to control our reproduction. In short, since we can control when we can avoid pregnancy, we naturally assume that we will be able to control when we have a baby as well. However, while many of us learn that unprotected sex leads to babies in sex ed, sex without contraceptives does not automatically lead to having a baby. For most healthy couples, it will take months to conceive a baby that is successfully carried to term. So I want to spend a few minutes thinking about this experience. If you're listening to this talk, it's because a sperm successfully fertilized an egg. The fertilized egg then underwent a series of cellular divisions before implanting itself in your mother's uterine lining, burrowing deep to obtain nourishment from her blood vessels. While many of us tend to focus on childbirth as the most dramatic and dangerous moment in the journey to conception, the most common complication during pregnancy is actually miscarriage. More than half of US adults believe that miscarriages occur in fewer than 5% of pregnancies. In reality, somewhere between 50 and up to 75% of conceptions are lost. Even if you had healthy parents who timed their unprotected intercourse perfectly, odds were greater you wouldn't be here as an individual than that you are. So some might be tempted to view such high rates of early pregnancy loss as a sign of inefficiency in this biological system. But is it? As discussed in the introduction, human babies take a lot of energy in terms of time and resources to grow. And this means that our bodies have evolved to invest in offspring only when we have the resources to do so. Thus, during periods of energy scarcity or high psychosocial stress, our bodies have evolved subconscious mechanisms to either avoid pregnancy or to spontaneously abort them. One of the pathways that our bodies can use to avoid pregnancy is to not ovulate. Ovulation is the release of a mature egg from the ovary into the fallopian tube and is understandably a necessary step for fertilization to occur. When we experience stress, whether it's nutritional or psychosocial or otherwise, there are changes to the release of reproductive hormones that can actually influence whether or not we ovulate. And so this is one mechanism through which the body can avoid pregnancy if conditions are not good. Stress can also increase the likelihood of pregnancy loss if conception has occurred. This has been really well studied in patients undergoing IVF, since they tend to be highly stressed and are intensively studied. As an example from the anthropological literature, a biological anthropologist, Pablo Nepomniachtchi, who's worked for decades with the Mayan community from rural Guatemala, measured urine levels 3 times a week for a year among married women who are not currently pregnant or using birth control. He found that women who experienced early pregnancy loss had significantly higher cortisol levels than women who did not, indicating that being more stressed could have contributed to early pregnancy loss. Sometimes pregnancy is avoided or lost not because of maternal conditions specifically, but rather due to stressful environmental conditions. As one example, during the COVID-19 pandemic, researchers evaluated average monthly birth rates beginning in 2018 across 24 European countries. They found that in January 2021, 9 to 10 months after the first COVID-19 pandemic-related lockdowns, there was a 14% reduction in live births. What's also interesting is that there may be sex differences in offspring sensitivity to environmental stress. So as one example, Ralph Catalano and colleagues studied sex ratios before and after the Great East Japan earthquake of 2011. Using data on birth rates across different regions in the country over nearly 6 years, they found that people living in the parts of the country most impacted by the earthquake were significantly more likely to miscarry male than female fetuses. This is thought to be because males, since they're larger on average and therefore have greater energetic needs, may be more sensitive to environmental stress. The interpretation from this work is that natural selection acts on mothers to increase their total number of offspring, sometimes at the cost of having an individual offspring at a certain time. In other words, it may be advantageous to wait until maternal and environmental conditions improve before investing in an energetically demanding offspring. Before moving on, it's worth noting that other species have developed alternative strategies for dealing with how to reproduce in unfavorable times. One example is where parents delay embryo implantation until a better time, referred to as embryonic diapause. And these delays can be on the order of days to months and occur in a broad range of species such as bears, weasels, kangaroos, armadillos, and some deer. And so this figure here is showing embryonic diapause in deer. The idea being that fertilization occurs and that fertilized embryo actually waits to develop until later in the season so that the baby can be born in the spring. Besides this strategy, some animals are also capable of sperm storage for long periods of time. In one exceptional case, a female rattlesnake was captured and held in captivity in isolation, and then later gave birth 1 and 6 years later. So all that to say that our strategy of delaying reproduction until conditions improve is not the only one that could have evolved, but it is the one that we ended up with. So even when conditions for mother and the environment are favorable, the energetic demands of human offspring means that there's strong incentive to only invest in offspring that are considered of good quality or likely to survive. So how is quality assessed? A study of 1,000 biological samples of miscarriage found that 58% of those miscarried samples had some type of chromosomal abnormality, making chromosomal issues a leading cause of pregnancy loss. But what does that mean exactly? So normally, each egg and sperm carries 23 chromosomes, 22 of what we call autosomes, and 1 pair of sex chromosomes. When they combine, the fertilized egg carries 46 chromosomes. Since chromosomes carry all of the genes that provide instructions for how to build a body, missing a chromosome or having an extra one means that thousands of genes are either added or subtracted. And as a result, the instructions for building the body are thrown off. So these chromosomal abnormalities can occur in 2 ways. The first is through inheritance of abnormal chromosomes from sperm or eggs. These errors are more likely with older parental ages, which is why older parental age is associated with infertility, one of the reasons why. For eggs, the problem is that the proteins that help with chromosomal separation during cellular divisions become less accurate as we age. Another way that chromosomal abnormalities can occur is a result of accumulated errors as the embryo is developing. So what we're looking at here is a fallopian tube going to a uterus, and we see the embryo at different stages of development. And so as it's traveling down the fallopian tube over a series of days, it's dividing. And so during those divisions, it's possible for errors in chromosome numbers to occur. By the time the embryo gets to the uterus, you can be euploid, where it's all normal cells in terms of chromosome number, aneuploid, where they're all abnormal, and this is most likely if you've inherited an issue from the egg or the sperm, or it's mosaic, so it's a mix, and it can be a mosaic with mostly euploid or mostly aneuploid. Offspring with abnormal chromosome numbers often do not simply stop developing. Usually they're miscarried due to failed implantation. I could do a whole lecture on implantation. It's so interesting. But just to keep it pretty high level here. So once that embryo has made it to the uterus, it embeds in the endometrium. And so the endometrium is that bloody lining on the inside of the uterus that builds up every month during the menstrual cycle. And an important thing to note about human implantation is that it's really deep. So across different animals that gestate, we see that sometimes the embryos will just go on the very top of the endometrium, and sometimes, like in the case of humans, they really dig in there to get close to maternal circulation. And one of the ways in which this happens is that we have what's known as a decidualized endometrium. So nerdy, but to make it really simple, the decidualized endometrium just means that the endometrium has been modified in preparation for that embryo to implant. And so what's interesting about humans and only a few other species is that this preparation of the endometrium occurs every month in our menstrual cycle. Most other mammals do not do that. It only becomes specialized once the embryo touches the endometrium. And because of this, we menstruate, right? We have this monthly cycle. Most other animals don't. And so all of these things together mean that, since our endometrium is already prepared before that fetus comes, before that embryo comes, it's been argued that our endometrium acts as a biosensor of embryo quality. In other words, since it's already specialized and prepared before that embryo gets there, it's better suited to be able to interpret signals from that little embryo about its quality, right? Because that little embryo is sending out little chemical signals, and so the human endometrium is able to say, okay, you're a good quality embryo, you have the right number of chromosomes, welcome, you may implant. And if it doesn't, then it blocks implantation. And so, again, most species do not have this capacity, the mouse, for example. And so in the mouse, all of those embryos are going to implant, right? We have this choosy endometrium, which is one of the reasons why we have such higher miscarriage rates at this point of implantation. But it's argued to be potentially an adaptive mechanism to avoid investment in this energetically demanding embryo. Okay, there will be a test after. No, I'm just kidding. Okay. So that's a little bit about the biology and some of the adaptive hypotheses. But of course, pregnancy loss is a lot more than energy, right? And I think that just talking about this in such a dry academic way loses a lot of the lived experience of this. And so I want to think a little bit now about how the experience of pregnancy loss has changed across time. So last year, I went to London for the first time, and I only had 24 hours before needing to head to Northern England for a conference. So I had to be very strategic about how I spent my time. And as a really big nerd, my first stop, naturally, was the London City Archives. and the reason why I went there was that I was really interested in these records they had from this London hospital in the 19th century, because I wanted to see what sort of data they had, and just to try and understand, again, how experiences have changed across time. And so this is an example of an entry from this ledger. It's recording the person's age, how many children they've had, previous abortions or stillbirths, infant sex, etc. And so, these records go on row after row, year after year. And when I look at this, there's a lot of things that jump out. But one observation I was initially struck by were the data on previous abortions, which here index pregnancy loss, right? Either spontaneous or induced. So abortion's being used in a different way than we think about in the contemporary sense. When I look through the first 100 data entries on this page, there's a record of 23 such losses to 10 women. In contrast, the total number of children born to these women is 228. So from a total of 251 recorded conceptions, 9% are reported as lost. And this is a lot lower than the estimated 50% of fertilizations, or 30% after you take a test that we think are miscarried today. So this begs the question, were women in Victorian England experiencing fewer miscarriages, or is something else happening here? It's most likely, almost certainly the latter. After all, women in mid-19th century industrial London are not necessarily known for their superior health and maternity outcomes. Instead, women during this period, like for most of our evolutionary history, likely would have had no idea how many pregnancy losses had actually occurred. This is because our ability to know about pregnancy earlier than quickening, when the baby first moves around 20 weeks, is a relatively recent phenomenon. When my mom suspected she was pregnant with my older sister in 1982, she was in Australia, and the way she tested was what was known as the rabbit test. So this test, like modern pregnancy tests, measured a hormone, human chorionic gonadotropin, which increases in your urine when pregnant. The difference is that instead of peeing on a stick in the privacy of your home, the pregnant person's urine is collected by a physician, mailed to a lab, and injected into a rabbit. The rabbit's then killed a few days later, and its ovaries inspected to see if they had become enlarged from the HCG. While gruesome, the rabbit test, when introduced in the 30s, was the first highly effective and widely used pregnancy test. But it could be expensive, had to take place at a doctor's office, and took several days to get results, meaning that it was not something people were doing intensively before or even immediately after a missed period, when most pregnancy losses occur. So just for reference, the first modern at-home pregnancy kit that you'd recognize was introduced in 1988. And this was a clear blue lateral flow test that you'd be familiar with. But as described in the ads, it was something people would not take until after they've missed their period to see if they're pregnant. Today, pregnancy tests are the most common diagnostic assay used at home. There's all sorts of memes and social media things you can buy to commemorate your pregnancy test. It's become a moment, an important marker of pregnancy. You can take the test days before you've even missed your period. So this product, for example, advertises that you can take the test 6 days before you've even missed your period. And while these tests are potentially exciting to be able to tell that fertilization has occurred so early in the process, it also increases the likelihood of detecting a fertilization that will ultimately fail. Needless to say, this detail is left off of the marketing material. As Freudenschildt argues, that while tests advertise that they are 99% accurate if positive, they're really only 70% accurate in terms of whether you will have a baby in 9 months, once you account for subsequent miscarriage. So in summary, while we've always experienced pregnancy loss, our acute awareness of this loss is likely much greater now due to recent technological innovations around pregnancy testing. So thinking about this idea of early pregnancy loss, we've talked a little bit about the core biology, how in adverse situations the body may avoid pregnancy by suppressing ovulation, or how we have high rates of attrition during implantation. We've talked about how the evolutionary explanations for these processes are that there's selection for overall maternal reproductive success, sometimes at the cost of individual pregnancies. And I talked about this biosensing hypothesis about the endometrium, which I bet you had no idea was so exciting. And last, we talked a little bit about contemporary context. I didn't have time to talk about demographic and health shifts and how those may be impacting loss. But we did talk about how increased knowledge of early pregnancy loss through testing has certainly changed the experience of pregnancy loss. In terms of implications, I think it's really important for people to understand that early pregnancy loss is common and not necessarily a sign of individual failure or fertility issues. Many people who experience early pregnancy loss can go on to have successful pregnancies. And again, this awareness that early testing is increasing the likelihood that we are aware of loss might have implications for when people want to test, right? Or changing our expectations around testing and understanding the high rate of early pregnancy loss. Okay, I want to shift gears a little bit now and talk a little bit about the idea of due dates or gestation length. So if I take a look at the calendar for the month my daughter was born, like other professional women expecting a baby, I'd done my best to plan around what I was interpreting as an upcoming deadline. I was teaching a course, ironically enough, on pregnancy and birth that was set to wrap up when I was 37 weeks pregnant. In theory, that would have been perfect timing for getting through the term while still maximizing my leave since it was the start of summer break. But knowing the stats, I was aware that 1 in 10 babies come early, so I needed to make sure I had contingency plans in place in case babies showed up unexpectedly. I was so prepared for an early delivery that when my self-imposed deadline of the end of the school term came and went, I was annoyed and somewhat alarmed to think I could be pregnant for another 3 to 5 weeks. I'm certainly not the first or only person who has found the spontaneity of childbirth is difficult to reconcile with our contemporary cultural context, where 74% of American mothers are working and trying to plan their schedule around their birth. In interviews with American mothers, I've heard the spontaneity of childbirth described as disconcerting or, pardon my language, a mindfuck. So what actually determines when our babies will be born, and how has that been shaped by our evolution and culture? So as a starting point, many of you have probably heard the idea that human gestation lasts about 40 weeks. And we find, what's interesting is that we find that the distribution of births tends to inversely mirror the neonatal death rate. So that's what's shown in black there, suggesting that natural selection has optimized birth timing to be when the likelihood of infant survival is the highest. This is because to be born too early might mean being born before you're developmentally mature enough to make the transition to the outside world. Conversely, being born very late can increase complications from giving birth potentially to a very large baby or reduced efficiency of an aging placenta, for example. So birth timing needs to be just right from a sort of Goldilocks perspective. Developed enough, but not too much. And so as a starting point, I think it's helpful to think about the length of human gestation in relation to other mammals. So on the x-axis here, on the y-axis are weeks of gestation, and at the very bottom we have a house mouse, which is about 3 weeks, and at the top of this figure we have a elephant, which is 92 weeks, right? So humans are somewhere in the middle of this distribution at around 40 weeks. The mammal with the closest gestation length is a cow. So there's actually, when I was looking up history of gestation length estimates, a lot of people talk about cows. Humans are like cows. But what you'll notice is that gestation length tends to mirror life expectancy and body size, right? So there's these trends across species, but we're the same as cows because, again, ours is a little bit longer than we might expect given our body size. Okay, so we throw this number of 40 weeks of gestation length around all the time, but how accurate is this 40-week gestation length estimate, right? Do we actually give birth at 40 weeks on that due date we all think of? So these are data from Scottish women in the 1980s and 90s. Mind you, as an anthropologist, I just want to preface this by saying that we expect a lot of human variation in any sort of biological trait. And so, yeah, these are data from Scottish women in the 1980s who were followed as they gave birth spontaneously. And they're all healthy women, and the researchers were interested in trying to understand when do people go into labor spontaneously in this population. And so here I have labeled the 280-day due date. And as you can see, less than half of people had actually given birth by 280 days. In fact, 50% gave birth by 40 weeks and 5 days, and 75% of first-time mothers gave birth by 41 weeks, meaning that a full quarter of healthy mothers had not given birth by 41 weeks. All right, so just giving you a sense of the range of natural human variation. So where does the idea of a 280-day gestation come from? We can thank this bloke, Franz Nageli, a German obstetrician who was working in the 19th century. And again, there's a lot more history here I can't go into, but to put it very shortly, he estimated that human gestation lasts 10 cycles of 28 days, right? Because our menstrual cycle is estimated to last 28 days, and so 10 cycles is 280. And so from this, we get the Naegeli rule, where you add 9 months and 7 days to the first day of the last menstrual period, and that's what gives you your due date. So as an example, if we became pregnant today, on the day of this seminar, we would expect to give birth on November 4th. But of course, as you might imagine from my sarcastic tone, due dates are not that accurate. There's a ton of human variation. In fact, somewhere on the order of 3 to 4% of births actually occur on their due date. And this is because, there's lots of reasons. One of which I already alluded to, the fact that most menstrual cycles don't actually last 28 days. So we now know that a healthy menstrual cycle can last 21 to 35 days. This estimate also assumes that ovulation is occurring on day 14, but of course that can be quite variable as well. And so all this to say is that when we estimate due dates based on last menstrual period, there is understandably a lot of variation and error in that estimate. Also, as an anthropologist, I appreciate that there's going to be a lot of factors that influence a trait like gestation length, right? So just like menstrual cycles are variable in length, so too might we expect that gestation length is variable. And in fact, now that we have a lot more studies, we find that factors like maternal age and how many children, or if you've had children before, if you're giving birth to a singleton or a twin, your birth weight, the child's sex, or even maternal BMI or other factors can all influence the rate at which baby's born and when baby's ready to come out. And so all that to say, the due date is an estimation, not an expiration date, right? and so this is reflected in the fact that term is, a 5-week period, but I think that in our cultural interpretation of due dates, that is not something we often think of. And so all that to say that there's a lot of variation, what actually or who actually makes birth happen or start, right? Is this something that's driven by the mom or by the fetus, a combination of the two? So a person who did a lot to help us understand who it is that initiates labor is this bloke here, Sir Graham Collingwood Liggins. And he's a really famous Kiwi obstetrician researcher. When I was in grad school, I actually worked at the Liggins Institute, which is named after him. And again, since he's in New Zealand and sheep outnumber people 13 to 1, he worked with sheep and not humans. And so Liggins' really important intervention is that he performed surgeries in an abandoned shed where he removed the hypothalamus gland from the fetal sheep and then also administered synthetic hormones in its place. And from these experiments, he found that, well, at the time, it was believed that maternal biology is what drives the birth process. In fact, it's actually signals from the fetus. And so in the sheep, I won't make you learn all of these things, but something I'll highlight is that in the fetus, a hormonal cascade is activated that results in the release of cortisol, which perhaps in our popular imagination is always a bad thing. But actually, cortisol is a metabolic hormone with a lot of really important functions. And during development specifically, it's really important for the maturation of fetal tissues, in particular the fetal lungs. It makes it so that the lungs don't collapse after a baby's born when they come into the extrauterine environment. And so this fetal cortisol surge is found in sheep. It's also found in people, by the way. And in sheep, it leads to changes in the ratio of progesterone to estradiol that basically causes labor to start. And so the simple takeaway from this is that the fetus initiates the timing of birth, and ideally this is happening when the fetus is developmentally mature, right? So the fetus is undergoing these hormonal cascades that prepare it for the extrauterine environment, and then it signals to mom, hey, I'm ready to be born. Let me out now. And this idea that progesterone levels go down when pregnancy or when labor starts is actually found across many different species. It's led to this hypothesis of what's called the progesterone block of labor. The idea being that when progesterone is predominant during pregnancy, labor doesn't happen. And then when progesterone goes away, labor can happen. But the mechanism for how this works varies a lot across species because why shouldn't it be as complicated as possible? I guess something really quickly to note is that while in sheep, for example, or in the mouse, progesterone levels go down at birth, in humans they don't. They don't actually go down until after the placenta is born. And so instead in humans we have a functional reduction of progesterone because there's changes in receptors on the uterus that are impacting how progesterone is impacting the uterus. All of this leads to an interesting question. If in humans and sheep, babies aren't born until they're developmentally mature, then why do we have situations where some babies are born before they're developmentally mature, right? In the case of premature labor. And in this instance, the idea is that there are certain types of stressors, whether it be infection or psychosocial stress, that influence inflammation in the placenta. And the result of that is it basically causes this progesterone withdrawal earlier. So that birth is initiated. And while obviously it's optimal to come out once you're developmentally mature, it's been hypothesized that if you're in an intrauterine environment where you're being exposed to infection or high amounts of stress hormones, then being born prematurely is an adaptive response, right? Even though it's not ideal, it is an adaptive mechanism to say, it's not working in here. I'm going to try my odds on the outside. And so that's one potential explanation for this. So aside from spontaneous labor being initiated when baby's fully baked and ready to come out, or preterm labor, which may cause baby to come out earlier, what's amazing about the world we live in now is that we're actually able to have interventions that allow babies to be born before the onset of spontaneous labor, right? And so this is relatively new. This is in the case of planned cesarean section, for example, or induction. But what's important to note is that not only are these interventions new, they're also being used a lot more in the last 30 years. So as an example, on the left, we're looking at cesarean rates in the US. Starting in 96 to 2010, the rate is pretty consistent in the US since then. But basically, a third, almost 3 out of 10 babies are born via cesarean in the US. And we've also seen an increase in inductions as well. And just to kind of put all of this together, using data I found from 2013, a full 40% of births were either a planned cesarean or induction, right? So are occurring before spontaneous labor. So this is an increasingly common part of the birth experience for many people. And of course, sometimes these interventions occur due to medical indications, right? So there are things that can be quite dangerous, like hypertension or high blood pressure in pregnancy, preeclampsia, gestational diabetes, other factors. What's really interesting, though, is that while these are all objective medical conditions, the ways in which some of these conditions are diagnosed or even how they're managed actually vary based on where you are, right? So if you are a pregnant person, depending on what country you live in, the way, when and how these interventions might be implemented could vary, right? So there's still, even though there's the biological experience, there's still the cultural reality of how these things are managed and whether or not you'll end up with an induction or a C-section. I think another really interesting part of these medical interventions is that they actually allow the pregnant person to have a control over the timing of their delivery in a way that wasn't previously possible, right? And so what's interesting is that, going back to when I talked about the idea of people feeling like we have control over our reproduction and feeling unsettled when we don't, interestingly, people use these interventions as a way to get control. So as an example, I just pulled this from Reddit in a chain talking about inductions. But somebody wrote, I was induced twice, it was amazing, and I felt somewhat in control. Planning childcare for my first, having a say in interventions, mentally preparing for what's next, I highly recommend, right? So it's really interesting how these interventions, again, sometimes are the result of kind of clinicians and clinical factors driving that, but also are an elective decision that people are making. And something that wasn't reflected in that comment, but which has come up a lot in conversations I've had with people, is about how the spontaneity of birth timing doesn't necessarily work well with contemporary work schedules. So after all, how do you know when to hand off projects? Or if you're a shift worker, how do you know what shifts you can or can't sign up for when a baby can be born across a 5-week window? And I think this is more of an issue now than it has been in the past because, like I said before, 74% of American mothers are now employed part or full-time. And our cultural context, particularly as Americans, is really not set up well to deal with the spontaneity of birth timing, given that most people have insufficient access to any paid leave. So from that perspective, someone might argue that we have a biological system that's really at odds with our contemporary culture that's not designed around the flexibility of timing that having birth actually requires. And so some people choose to manage that mismatch, not unreasonably, through medical intervention. Okay, so to wrap up this section, I want to highlight that as a result of both medically indicated and elective interventions, the mean gestational age of delivery has actually decreased by more than half a week over the span of 30 years in the US. This is not universal, right? So if we look at average gestation length in the US compared to Netherlands, for example, they have not seen such great reductions, again, because of differences in medically indicated, but also elective interventions. And so I think it's just quite remarkable to think about how a trait that's been under such strong selection for millions of years is able to change so quickly. And it begs the question of longer-term mental and physical health impacts, if any, there might be for parents and babies. So this is something we just have to study with more time. So in terms of some summary for due dates, we talked about the core biology. Gestation length is variable across and within species. In humans, at least, and sheep, parturition is initiated by fetal signals of maturation and functionally occurs through the withdrawal of progesterone. In terms of longer-term explanations for gestation length, our general gestation length has been influenced by our body size, and premature birth may occur when uterine conditions are suboptimal. And last, in terms of contemporary context, medical interventions have shortened the average gestation length, particularly in the US. And I might argue that the unpredictability of spontaneous birth timing can contribute to anxiety for some people. So in terms of implications of this, I think it's really important for people to understand that the average gestation length is not 40 plus 0 days. There's actually a lot of variation. We need more research to understand the impacts of birth before physiologic labor, particularly since it's an increasingly common experience. And I might add that more robust parental leave policies could potentially mitigate some of the anxiety around the unpredictability of birth timing. So what are the overall takeaways for this? First, I want to make the point that reproduction is a process that's been strongly shaped by our evolution, both biological and technological and cultural, right? It's not just one or the other. Many biological characteristics evolved to enhance our overall reproductive success, not necessarily our happiness. And understanding our evolved biology might encourage us to work with rather than against our biology when possible. So to close, I want to make it clear that while this talk has addressed some of the unpleasant, painful, or even dangerous aspects of the reproductive experience, it's important to keep in mind that reproduction is not all terrible. Gotta say it. Every problem that I'm talking about in this book is a side effect of a system that, on average, works. After all, each of us are in this room because women across our matriline were able to reproduce successfully. The fact that these trade-offs sometimes produce discomfort or adverse outcomes in the short term does not mean the whole system is bad. It simply reflects the constraints under which our evolution operates and the cultural context within which these evolved biologies are experienced. So thank you very much.
We have time for a few questions. First question.
Earlier in your talk, you were going over the 28 days stuff. Has any of your research touched on correlations as to whether the culture believed in a lunar cycle or a sidereal cycle for the calendar?
Yeah, great question. So the 28-day cycle thing was the Nagley specifically. That was his model. But prior to that, there are certainly a lot of folk traditional models that estimated pregnancy to be 10 lunar months, right, which would give us a gestation length of 295 days. Interestingly, I did like a deep dive on history of pregnancy durations. Another estimate people came up with was from the Bible. So if you actually count from the day of conception, so Annunciation Day, perhaps, to Christmas Day, it's 275 days. So, you know, the fact that these aren't so far off suggests that people have an awareness, but also people's understanding of how far along you are was probably a lot more influenced by, you know, hands-on feeling of where people are, like physical symptoms and signs. So yeah, it's changed a lot across time. Thank you.
This isn't a question, but I'll relate an experience and you can tell me what you think. My first child represented the combination of the technological and the natural. Mm-hmm. My wife fairly early had premature rupture of membrane. Mm-hmm. And they ran the hormone test they do for the surfactant of the lungs, mm-hmm. and it was too low, so it was obvious. Mm-hmm. And she was on bed rest, mm-hmm. and once literally not moving at all because they really wanted to postpone it as long as they could, except for once a week where I'd take her for a blood test. And once they decided the surfactant mm-hmm. was at an mm-hmm. adequate level, they said, get her up. We walked around for the afternoon, and she was in labor that evening.
Interesting, yeah. Yeah, and so that reminds me, I told you a little bit about Liggins, but part of the reason why he's also famous is that he followed up that study with, one of the things he noticed with the lambs that were induced prematurely was that when he gave them when he started the cortisol exposure, even if they were preterm, they could breathe. And so he then worked with a pediatrician to develop the first clinical trial to administer synthetic glucocorticoids to people at risk for premature labor and see if it improved respiratory issues. So that treatment is actually a direct result of Liggins' work.
Thank you so much for that really interesting talk. And I want to go back to the difficult topic of infertility. And I'm wondering, you know, I realize that there's a lot of TikToks, a lot of Instagram posts about infertility and what you can do to boost your infertility. But I was wondering how we might compare infertility today. So women that are in, you know, the birthing age of 30s, or late 30s or 20s, and previous generations, let's say 2 to 3 generations in the past, not looking too back deep into the Victorian area, you know, but you know, what has the research said about infertility most recently? Because, you know, I do have I'm around that age, and I do have a lot of friends too that, you know, we're concerned about how it is that it seems that I think every generation thinks that they're the worst or that they have these problems, but, you know, what can be said about infertility today compared to not too long ago?
Yeah, thanks. So, you know, in this talk, I didn't get to talk at all about kind of proximate factors that impact infertility, but obviously things like age and metabolic status and even exposure to toxicants are all factors that can influence our fertility. And we know, of course, that demographic shifts mean that we give birth later now than we did ever before. And so, of course, that in of itself is going to lead to challenges. Also, aspects of our nutritional environment that have changed, again, might increase the risk of metabolic sort of disorders that might increase difficulty in conceiving. And then again, exposure to environmental toxicants, some of which act as like endocrine disruptors, right, and can impact a lot of different aspects of the whole fertility process. And so there's a lot there. I think that, you know, another hat I wear besides studying pregnancy and birth is studying stress and health. And so I think that something I try and think about a lot after a lot of years of working in that space is that there's a lot of things that are outside of our control. So what is actually in our control? And I think actually in this project, I haven't quite gotten there yet, but one of my goals is to help people understand, like, yes, there's all these things that are difficult. Some of these things are out of our control, but what pieces actually are, and having people focus on that because that's actually productive. And so in the case of infertility, you know, if we want to reproduce in our 30s or 40s, right, then like what are the things that we can do to optimize the experience we're at and not worry about all of the environmental exposures that we can't control. So didn't answer your question exactly, but yeah.
Thank you. Thank you for that wonderful talk, deep research on so many levels. I want to pick up on what you were talking about control. It does seem like this is a particularly difficult moment in our society in terms of unpredictability. And not that that necessarily weighs in on the choice to decide on an optional or an elective, as you called it, kind of surgery in advance of spontaneous labor. But it does raise some questions for me about that distinction between elective and medically indicated. Because it's like with the CRISPR technology and being able to figure out what kind of birth, what kind of child you're gonna have, like potentially that's there. To be able to control is not, I would think, not available to a lot of people. Financially, maybe insurance-wise, it's probably not covered. So I'm just curious if you can project forward in time to this, you know, way we relish control in the society and how that might actually play out, you know, come a few years from now, when it seems highly desirable to know when you're going to give birth for all the reasons you suggested, but it's not a stretch. And I'm curious if the U.S. is on the cutting edge of the, you know, frequency of elective surgeries, and also whether you know you really see this as a way that we're going to be moving and leaving out a whole lot of people.
Yeah, thank you. So there's so much there. I mean, just if we think about the procedures that I talked about, cesarean section or induction, the prevalence of those interventions vary a lot globally. So as an example, you know, I do field work on cesarean sections in Brazil, where almost 60% of babies are born via cesarean. And actually in private clinics, which are where people who have financial resources go, right? They're the private, not the public system. It's 90% of babies are born via cesarean, planned cesarean, via cesarean. And so obviously a lot of those are elective procedures, and that's much higher than what we see in the United States. You know, in the US, our cesarean rate is, you know, just over 30%. In terms of planned cesarean, it's like, I don't remember, 12 to 15%. And then within that planned cesarean, like the elective cesarean is only going to be a couple of percent. Although in all of these cases, it's very difficult to really get accurate data about it. As an example, I have a friend who wanted to have an elective first cesarean, planned cesarean, because she was terrified of birth. But her doctor told her that insurance wouldn't allow that to happen. And so they helped her by putting in her chart that her baby was large for gestational age. So now it's medically indicated, right? And so like the reliability of these data can be really sketchy. On the point of induction, the rate of induction, the data are also not great in terms of how many babies are induced or the causes for induction, that whether it's elective or what the cause is specifically, because that's not consistently collected. But there was a big study published in 2018 called the ARRIVE trial, which suggested that elective induction at 39 weeks did not carry additional risk for the newborn, but it was associated with an absolute reduction of 3% cesarean section. And so this encouraged a lot of people to now say, all right, we can induce at 39 weeks, and it's a good thing. And so the study has been a little bit controversial, and it hasn't necessarily impacted inductions in the same place in other countries. And so all I have to say is it's really complicated. It's hard to know where it's going to go. As a researcher, I'm quite interested in just trying to think, because as I suggested, about what are the impacts of not experiencing physiologic labor. I think that every person should have autonomy and be able to choose whatever they want to do. But I also think that every person should be able to do that with the best possible information of all of the risks and benefits and alternatives for procedures. So that's kind of where I land. Yeah.
When my mother talks about my birth, it is clearly that it wasn't for her convenience that the induction was done. So I was born right after the war. There was an excess of babies and a shortage of beds. And so she says they lined up gurneys of 10 or 15 women in the hallway. The doctor went down the hall and put each one, or a nurse did, put each one on a Pitocin drip. And then they went back and caught babies, is how she describes it. So I'm curious then, in your research, do you find that the convenience of the caregivers is sometimes the cause of controlling birth rather than the wishes of the mother?
Yes, 100%. And I'm sorry if I gave that if I implied that at all. There are absolutely a lot of stories and experiences that people have of being, pressured into an intervention that they would have not preferred. Obviously, there's a lot of power dynamics. Your provider tells you that you need to have this intervention or your baby's going to be stillborn or die, right? Like, people don't want to go against that. And so that's where I tried to make the point that those guidelines vary across cultural contexts, right? But you're absolutely right that oftentimes these interventions can come from the provider side as well. I was just trying to show that in some instances, it's also initiated by the patient, I think, because we don't talk about that a lot as much as the other side. But thank you for mentioning that.
Well, any other questions? Well, please join me in thanking Professor Thayer.